Hey everybody, we're going to talk a little bit about Sig Figs and the types of tools we use in chemistry class or other science classes. The tools we use have varying degrees of accuracy associated with them. And one thing you need to remember is that every measurement we take, no matter how good the equipment is, there's always a degree of uncertainty. It's never a perfect measurement. So I thought I would use these very common glassware examples today, and you should learn the names of them. You've probably used these two, I would imagine, in the past, but a graduated cylinder, a beaker, and you probably haven't used this yet, but an Erlenmeyer flask is another common piece of glassware that we would use. And I have this question I've posed here. Which glassware is best to deliver a measured volume? There's only one of them that is best for that, shown here, and that would be a graduated cylinder. A graduated cylinder has a lot more little tiny graduations along its surface there, as compared to a beaker or Erlenmeyer flask. So the more graduations there, the more likely we're going to be able to measure something accurately. And this would be good if I asked you in the lab to get me 55 milliliters of water. I would never want you to get it measured from a beaker, and I would never want you to get it measured from an Erlenmeyer flask. I would want you to measure 55 milliliters of water with a graduated cylinder, and then if needed, you could pour that liquid into a beaker or Erlenmeyer flask for storing liquids. So if we look here, a graduated cylinder, for example, could have the smallest division or graduation being 1 milliliter. What that means is, as a general rule of thumb, is that we can estimate or have a reading error of 1/10 of the smallest division. So that would be 0.1. Okay, milliliters, plus or minus. And what that tells us too is we would have 3 sig figures or significant figures possible. So from that graduated cylinder, I could have a logical reading could be 35.5 milliliters from there, because we could go to that 10th position where we have that estimate. So by definition, significant figures are all certain numbers plus one estimate or estimated number. Okay, so we are certain that there's 35 milliliters of liquid, and we have a decent estimate of 0.5 milliliters. So let's look on to the beaker example. I mean, if you could see, I've got it, the smallest divisions in 10 milliliters. Okay, that means we can say that the reading error is going to be 1/10 of that, which is 1 milliliter. And therefore, the number of significant figures that we can obtain from a beaker reading would be 2 sig figs. So an example reading could be 37 milliliters from that beaker. We are pretty certain that it's 30, and we are estimating that there's 7, okay? Finally, the Erlenmeyer flask. In this example, we have 200 milliliters as the smallest division. The reading error is going to be 1/10 of that, or in the 10 milliliter range, okay? And in that case, you could still have 2 sig figs. And, just using an example, 220 milliliters, we are certain. At the 200 range, we are estimating at the 20, could it be 230, could it be 240? Certainly, okay? All right, so let's go on to that Atlantic Pacific rule that you watched that short video before. And I'm just going to review that and give a few more examples. So we have our United States. I love the Atlantic Pacific rule, by the way. I think it's a great, simple way to determine how many sig figs are found in a number. So we've got the Pacific Ocean, we've got the Atlantic Ocean. If the decimal is absent, we're going to go into the number from the Atlantic side of that number. If a decimal is present, we're going to go in on a number from the Pacific side. Let's make more sense of that using these examples. So in extended notation, I've got 4 examples. Let's determine the number of sig figs using the Atlantic Pacific rule. I've got a decimal present. I'm going to come in on the Pacific side, and I'm going to start reading the numbers from the first non-zero number. I have 1, 2, 3 sig figs here. Now, what's really important is these are called place holders or place keepers. You can't get rid of those zeros. They have to be there because this is a really tiny number. It's a placeholder, a place keeper, but the only significant numbers are 6, 8, and 2. And in scientific notation, just to do a little practice there, 1, 2, 3 decimals to the right, we have 6.82 times 10 to the -3. It can be written in scientific notation. Let's look here. We've got a decimal present, Pacific rule. I'm coming in. The first non-zero number is that, number 1. And every number after that has to be significant. There are 4 sig figs. Writing that in scientific notation, and all of those numbers are significant. So another, by the way, you'll notice any zeros that are between 2 non-zero numbers are always significant. Now let's look carefully at these 2 examples, 300 with no decimal point and 300 with a decimal point. Well, the decimal is absent. I'm in the Atlantic side. I'm going into the first non-zero number. There is only 1 sig fig there. Of course, we're not going to get rid of these. Why? Because these are placeholders, these zeros. So they are important to be there, but they're not significant figures. How would I write that in scientific notation? 3 times 10 to the 10 to the second power. We have a decimal present. We come in on the Pacific side. The first non-zero number is the 3, and every number after is significant. There are 3 sig figs in this example. And we have to actually write it differently in scientific notation because of that. Since these are significant, they're not just placeholders. We are going to write it 3.00 times 10 to the 2. And again, all these numbers are going to reflect the degree of certainty that we have in a measurement. And sig figs are all certain numbers plus 1 estimate. I have one more example using this common tool, our metric ruler. Now, of course, we do have the inches here, and we have the metric system down here. In science, we always want to use the metric system. If I go to measure this Post-it note, first of all, you're going to notice that the little lines, the smallest unit of measurement is the millimeter reading. So there's centimeters, and then millimeters is the smallest unit. So we can estimate that this is, the error reading would be 0.1 or 0.1 millimeters. Okay, so this one you can actually get 3 Sig Figs from. Okay, and if I just, look at this, it looks to me like this is a 7.5. I'm pretty certain it's 7.5, but I'm going to say it seems to be right on that 0.5. So there's my estimate. Certain estimate. 3 Sig Figs. Okay? All right, hope this was helpful. Bye.